Okay, so on this one, label this one measures of variability. And this one probably is new to you, okay? And let's look at a basketball team, okay? Let's consider a basketball team. And the average height, if you're, think about this, if you're the opposing coach, average height, 5 feet, 10 inches. And what would that be in inches? 70 inches is their average height. And there are 11 players. Okay. Now, I'm gonna do some columns across the page. Okay, in the far left column, we're going to put their height in inches. So write these down. 63, 65, 66, 68, 68, 470s, 73, and 87. How tall is that guy? 87 inches. 7'3". If I was the opposing coach, if all you told me was their average height was 5 feet 10, oh, not a problem. Until you hear about this 87 inch, 7'3" guy, I'd want to know if I was the opposing coach. Okay, so these are their heights. Okay, and if we added these together, I know their average is 70, so this is actually 770 if you add those up. And then if you divide 770 divided by the 11 players, we said their average height was 70. That's actually the arithmetic mean. That is the X bar. Okay? Okay. So it's 770 divided by 11. Their average height is 70. But I'd want to know that individual, and that 87 guy is actually an outlier. His data is way off everybody else, so that's called an outlier. Okay, on the next column, we are going to put the difference between the mean and their height and the absolute value of that. So if I took 63 minus 70, be negative 7, and I want the absolute value of that, so that would be 7. And this is actually the difference from the mean. Our mean was 70, and it's the absolute value of it. Okay. On 65 would be 5, 66 would be 4, 68 would be 2, 2, and then 4 zeros, and then 3, and then 17. Okay. And then if you add those up, you would actually get 40. If you add those, and then if I take 40 divided by the number of players divided by 11, I would get 3.63 with a bar above the 6.3. This is called, this has a special name. It's called the mean deviation. In statistics, it's got a special name. It's the average of the deviations. So each one of these up here, these are called deviations. The difference from the mean is called the deviation. Okay? Now, that's just doing it arithmetically. Here's what it would look like in the statistics book for the formula. Mean deviation is an uppercase M, an uppercase D. Okay, and the formula is 1 divided by n, 1 over n, times the summation of the absolute value of the x sub i's minus the arithmetic mean, the absolute value of that from I equals 1 to n. So what we just did up above was this. We subtracted the mean, we took the absolute value of it, we added them all up, and then we divided by n. Okay? Okay, now in the next column, we want the square of the deviations. Okay? So it's the square of the deviations. So you'd take 7 squared, it'd be 49. 5 squared, it'd be 25. 16, 4, 4, then 4 zeros, 9, and 17 squared is 289. So those are all the squares of the deviations. If we added those up, we would get 396. Okay? Then take the 396 and divide that by 11, the number of players. Okay, and you would get 36. This 36 has a special name. It's called the variance. Okay, then if you take the square root of the variance, take the square root of 36, and we're considering just the positive. Okay, and that 6 has a special name. That 6 is called the standard deviation. The standard deviation. The standard deviation has a special symbol. It is the lowercase sigma. This one is the uppercase sigma. Okay, the lowercase sigma kind of looks like this. Okay. And you'll see it on the calculator in a minute. Okay? So, to get this standard deviation, here's what we actually did. The standard deviation, or sigma, is the square root of 1 over n times the summation of the x sub i's minus the arithmetic mean. We took the square of that from I equals 1 to n. So that's what we actually did when we worked that problem. We added up all the squares of the deviations, and then we divided by 11, and then we took the square root of it. Okay? And that is the standard deviation. Now, so you learned some key words. Now, what does that standard deviation do for you? Well, it tells you how much your data is spread, and let me show you. Let me give you an example. First, we need to do a little bit of notes. In what they call a normal distribution of data, in a normal distribution, and some of you may have heard of that as the bell curve. In a normal distribution of data, they might call them data, they might call them scores. In a normal distribution of data, approximately 68%, or roughly 2/3, of all the scores lie within one standard deviation on either side of the mean. Okay. Roughly 2/3 or 68% of the data lie within 2/3 of the mean. Okay. 95% of the data lie within, and just use just S D for abbreviation, 2 standard deviations of the mean. And 99% lie within 3 standard deviations of the mean. That's in what they call a normal distribution. It would look like this. In a normal distribution, it will look like a bell curve because it looks like the old bell. Okay, and if you were looking at a graph, okay, this in the middle would be your arithmetic mean. That would be your X bar. And if it was a normal distribution of data, 68% of the data would lie in here. So this would represent 1 sigma. This would represent a -1 sigma. So this point is actually the arithmetic mean plus 1 standard deviation. This point would be the arithmetic mean minus 1 standard deviation. If I went out from the mean another standard deviation, okay, then this one would be the arithmetic mean plus 2 sigma, and this would be the arithmetic mean minus 2 sigma. And if you did that, then within this whole thing here, 95% of the data would be in there. Okay, and then the other one would be 3, there'd be another, and 99% of the data would be in there. Okay? Where you want to be careful with that is if you go into a college class and you say, the professor says, would you like your grades figured on a bell curve? Curve sounds, oh yeah, I'm going to put it on a curve. Okay, but the problem with that is, if your grades are figured on a bell curve in a class like this, an advanced class, 68% of you are going to get C's. Would 68% of you be happy in this class with C's? No. Okay. And then if I gave say 3 B's, then that means I'm going to give 3 D's. Okay, and that means if I would end up to give 1 A in this class, I'm going to fail one of you. Okay? So you got to be real careful how you answer that question. Do you want your grades figured on a bell curve? Now, it depends on the makeup of your class. In an advanced class like this, you want your grades skewed one way. And if I skewed them, and I always thought the skew was on this side, but the skew is actually with the tail. But it would be like, okay, I want to say, okay, 95% of you are going to get A's, you know, and so a certain percent are going to get B's. That's not a normal distribution of data. But even last week when Tanner O'Hara was here before Thanksgiving, and he was talking about one of his professors figures his test scores on bell curves. No, that's not a, you know, in an advanced class you don't want that. Okay. Okay. Now, what would our data look like? Okay, if we were doing our data up above, here's kind of what it would look like. If I said, okay, just pick and let's label this as our average height was 70, and our sigma was 6. So if we added 6, this would be 76, and if we subtracted 6, this would be 64. And then if we added 6, this would be 82, and subtracted 6, this would be 58. And if we added 6, that'd be 88, and subtract 6, it'd be like 52. And then if I just said this is 0, 1, 2, 3, 4, 5, okay? And if I said, okay, if I graph my data, I have 163, so I have one person about in here. I'm just estimating. I have 165, so I have one person here. I have 166. I have 268, so I'm going to go up to 2. I have 4 people at 70, okay, and I have one person at 73, so one about in the middle here, and I have 187. Here's my outlier. This person would be considered an outlier. It's way off the other data. Now, what you would check, is this a normal distribution? What you would do is you would look within 1 standard deviation of the mean, am I close to 68% of the data? So I'd say, okay, I have 1, 2, 4, 8, 9. I have 9 out of 11 people. Do 9 divided by 11 on your calculator. What do you get? What percent? So I have about 81, 82%, 82% of the data in there. So this would not be a normal distribution. This would be where more of my data is clustered within one standard deviation of the mean. And then within 2 standard deviations, I would have 10 out of 11, and you divide that. So this is not a normal distribution of the data. Okay? If it's a normal distribution, about two-thirds of your data is clustered around that mean. Make sense? Okay, now, how do you do it on the calculator? Okay, first thing on the calculator, you just got a couple minutes to do it. Okay, turn your calculators on. And I want you to do second function mem right above the plus sign. Okay, this should come up, and see that number 4? Clear all lists. Do clear all lists, number 4. Okay, and press enter. That clears all the lists out. Okay, now right about in the middle, go to stat. There's a stat button. Hit the stat button. Very similar to matrices. To get anything in, you got to do edit. Okay, so press number 1 for edit. Just press. Okay, and you should have some empty lists.
Which area is that? Like
Stat, and edit. It's right here. There's a stat button, stat and edit. Okay, now let's go back and type in our data. Okay, type in the 63 and enter. 65, 66, 68, 68, then you have 4 70s. Okay, and then we have a 73 and an 87. Whoops, and I made an error. 73 and an 87. Okay, now go back to the home screen, second function quit. Okay, do stat again, right arrow over to calculate. Okay, and we just put in one list, one variable. Okay, so do one variable statistics, number 1, and press enter. Okay, wow. Okay, it did the arithmetic mean of 70, the X bar. It totaled them up for us, 770. This part, you don't have to worry about that. This is a sample deviation. Here's your sigma. Okay, everything that we had to do to get over to that 6, that standard deviation, it calculated that. It figured the number of values. If you typed in 1,000 values or 987 values, that would be valuable. It counted them for you. It figured the minimum. It figured the first quartile point. 25% of the data is in here. It's like a box and whisker plot. That's the whisker. Okay. The median it figured. The third quartile point. So 25% of the data is in here. It figured the max. 25%. That's the other whisker. Okay. So you got the arithmetic mean. You got the standard deviation. You did not get the mode. Okay, you got the max, the min, the median, all in one quick thing. Okay.